Hello YouTube, welcome to my channel. I'm Sreetips, and I've got a collection of Karat scrap here that I need to get processed. And I've got two bins. One has some 14K in it, the other one has some 10K. And we're going to go ahead and quart this gold and refine it into a nice pure gold bar. Should be about around 9 ounces of pure gold. I've got my stock pot solution here. This will be my final stock pot refining video as soon as I get a chance to get this done and get the palladium out of it. And that'll be coming up next. But right now, what we're going to do is refine this Karat scrap into a nice pure gold bar. The first step is to weigh our material. This is the 10 karat gold. It's been cleaned mechanically. I've removed all the springs, all the stones, and all I have in here is 10 karat gold now. So what we're going to do is we're going to put our melt dish up here on the scale. I'm going to tear the scale to 0. And now I'm going to add the 10K gold to our melt dish here. Wouldn't it be nice if it went just perfect? Alright, we've got 245.6 grams of 10K gold. 10K. 245.6 grams. And now I'll measure the 14K gold. Tear the scale. Let's put our dish on here. Get the scale to 0. And then we'll add the 14K gold here. Alright, we've got 303.2 for the 14K. Here's the calculations that I normally do to find out how much silver I need to add to my Karat scrap in order to achieve about a 26 or 27% alloy of gold. Alright, one of my viewers wrote to me and said that I can do this calculation in one number simply by multiplying. I'm going to start with the 14K here. Simply by multiplying the amount of 14K gold that I have, which is 303.2 grams, times 1.265. So if I take 303.2 times 1.265, I get 383.54. 383.54. 383.54. That's how much silver I need to add to our 14K gold batch here. And if you look at the number that I've calculated up here, it's 384.29. So instead of doing all this math here, the fella wrote in and said just multiply your grams times this number and you'll get the proper amount of silver that needs to be added. It saves a whole lot of calculating. So I figured out what the number is for the 10K gold. I multiply this by 0.635. So I got 245.6 times 0.635 equals. That's 155.95 grams. And if you look up here, all this produced the same number, a little bit different, but not enough to make a difference here. For our purposes, this is good. All this math produced 156.1. Simply multiplying the number of grams I have by 0.635 gives me the amount of silver that I need. And that includes the 95% or the 5% reduction on both numbers. So all I have is one number to multiply for each of the carats to get my silver. I can eliminate all this math and get my numbers by using these two multiples right here every time I calculate for 10 and 14K gold for inquartation. Thank you. I can't remember the fella's name, but it sure does save a lot of time. Okay, I've got our silver measured out here for the 14K. Now we're going to do the same thing for the 10K. Measure out the silver. I need 155.95 grams, so I'm going to go ahead and measure some of that out here. This is silver that's all been cleaned up. There's 152. Nice. Pretty close. That's 156.1. I'm looking for 155.95 for the 10K. That's pretty close. We'll use that for the 10K. There's our silver and our gold that's going to be inquarted. I've got a metal container full of tap water here to pour the molten inquarted gold into to form the granules that I'll be treating with nitric acid. Can't use plastic, can't use glass because the metal stays molten all the way down to the bottom of that container. I'm doing this melt in two segments here because I have so much metal, so I split it up into two segments. We're going to go ahead and put this on now. This is the 14K. I'm going to start this up and we're going to start melting the carat gold so we can inquart it with silver. Here we go. All my experience with melting has been with these open face crucibles here. And what I'm going to do is, since there's so much metal, I'm using two torches. I keep the MAP gas torch on the crucible. Here I'm adding the silver pieces to create our alloy that we're after to make the inquartation. That's sterling silver going in. You see over there to my right, I've got a graphite rod there. I just picked it up and I preheated a little bit. And then I start stirring the metal with that graphite rod to make sure I get a good alloy. And I stir this metal for a good probably 60 seconds at least. When it feels like I've got it stirred enough, I stir it for another 20 or 30 seconds usually. Now there's going to be about 20 troy ounces of metal in that dish. But here you'll see me, I pick it up and I'm going to pour the molten metal right into the tap water in that metal container. And that will form the granules of inquarted gold for the next step. In this segment of footage, I repeat the entire process with the 10K gold. I start to melt and I realized I didn't put a piece of ceramic wool under that crucible. So I stop the melt, go over and get a piece of wool, install the wool, and then continue the melt. As I was melting and adding the silver to the 10K gold, I noticed there were some pieces of hard steel in there. It looked like iron or steel, and so I picked them out here with my tweezers. You'll see me do it right, let's see here, coming up. There's a couple pieces of steel. I'll pull them out. You'll see them red here, right there. Another piece right there. And then I'll continue stirring with the graphite rod. This crucible has about 13 troy ounces of molten metal in it, and that is another reason that I split these things up into two groups, because I didn't want all of the metal in one of those crucibles. It would have been around maybe 2 pounds of molten metal in those melt dishes, and I didn't know if I could trust those things with that much weight in them. Here's our unquarted gold. What I'll do now is get this tap water off of it, and we'll get it in some nitric acid and get all the silver and the base metals dissolved out of it. I've got the unquarted gold in this metal container. I'm going to pour off the tap water here. I'll get a look at this metal. Here's a look at the Karat gold. What we're going to do now is get this into a beaker. This is Karat gold that's been unquarted with silver. Now we're going to go ahead and dissolve off all the silver and the base metals with dilute nitric acid. I'm going to transfer the larger pieces into the beaker here by hand. These are fairly heavy, and I don't want to pour them in and have them break the bottom of the beaker there. I'm going to try to get the rest of this poured in here now, carefully. And I've got some distilled water here, and I'll rinse the pieces out with some distilled water. Anything that wants to cling in there. Okay, I'm going to rinse the gold off now with some distilled water. Can't use tap water to do this rinse, and we want to rinse the tap water off from the last process. So I'm using distilled water here to give this a good rinse. Get all the chlorinated water out of here. Chlorinated water will react with the silver nitrate that we're about to make when we add the nitric acid, and it'll form silver chloride in there, and that's something we want to try to avoid here. Here's our unquarted gold. Here is some used dilute nitric acid from a previous refining. What I'm going to do is start off by adding this nitric acid. It's dilute nitric acid that was used on a previous gold refining. I'm going to add it to the unquarted gold now to start this off. Alright, now we're going to put a lid on it, and I'm going to set it up on the heat. First, let's take a look at this reaction. It'll produce its own heat initially, and plenty of red fumes. So we'll just let that react in that container right there until this calms down just a little bit. The nitric acid goes to work immediately, dissolving the silver and the base metals off of that encorded gold. But remember that the gold itself will not dissolve because the nitric acid can't dissolve gold all by itself. I'm going to add about a half a liter of distilled water now, and then we'll get this up on the heat. Put this up on the heat now. Start heating this a little bit. Alright, that's about 250, 300 milliliters of concentrated nitric acid. I'm going to add a little bit of this to the beaker now. See if we can get this reaction rolling. That's about 100 ml or so. Should take off now. What's happening in here right now is Karat gold is alloyed with silver and base metals, copper, there's some possibly nickel in there, and what we're doing is using that nitric acid to dissolve the soluble metals, which is going to be the silver, the copper, brass, nickel, all that stuff. But the nitric acid by itself will not dissolve the gold. It will leave the pure gold behind. What will happen is those pieces of encorded gold in there, the nitric will start to burrow into those chunks and form a honeycomb structure as it dissolves out the silver and the base metals. And that nitric acid will go all the way through and eat all of that metal out of there and leave the pure gold behind. And when we get done with these nitric acid treatments, there will be some brown chunks of gold in there. Those brown chunks of gold will be very close to 3/9 fine gold without any further processing. It is 6:30 p.m. I started this process at 6 p.m. and in here I've got some undissolved silver, and what I'm going to do now is transfer the solution out of my beaker here because fume production has ceased. So I'm going to carefully pour this into my silver jar because it will have lots of silver in it. Okay, I'm going to rinse this out with some distilled water here, and we'll pour this rinse water into my silver jar, and then I'm going to add some fresh distilled water to the beaker with the encorded gold in it, and we'll put some more nitric acid in there, put it up on the heat, and continue dissolving out the silver and the base metals. I'm going to add some distilled water now. About a half a liter. And then we'll add some nitric acid. I've got about 200 milliliters in the bottom of this jar. Go ahead and pour this in. And then we'll put it back up on heat and continue to get the base metals and the silver out of this encorded gold. Let that simmer down a little bit before I throw it on the heat. That should be okay. Okay, this second dose of nitric has been on for about 35-40 minutes. I'm going to pull it down now, pour it off into our silver jar. Alright, we're going to go for our third nitric acid treatment here. I'm going to move this silver jar back out of the way. It's full. And then I've got another one up here. And we'll start filling this one up. I'm going to rinse the silver nitrate off of this gold. I'm going to pour the rinse water in my new silver jar here. This liquid's all going to contain lots of silver because the nitric acid is dissolving the silver out of the gold, but it won't dissolve the gold. It'll leave the gold behind. Here's what our quartered gold looks like. Almost look like bronze in there. Alright, I'm going to add some more distilled water to the encorded gold here. About a half a liter. And some more nitric acid here. This time I'm going to put about 200 or 300 in all at once. Here we go. Nitric acid going in. Alright, that was about 300 milliliters of concentrated nitric acid. And we'll just leave this off the heat for a minute or so. See what it's going to do. The time right now is 7:30 p.m. and I started this whole process back with the silver calculations around 5 p.m. And so we've been going now for about 2.5 hours. I'm going to set this up on the heat now. I think take it. And we'll just let that cook and remove all the base metals out of there. That dosage of nitric has run its course. Time right now is 8:40. So we've been doing this now for about 3 hours, 40 minutes. What we're going to do now is pour this solution off into my silver jar here. Alright, we'll rinse this down with some distilled water. And then we're going to set up and do nitric treatment number 4. Pour this off here. Add some distilled water to our imported gold now. It still kind of looks like bronze. It's got a ways to go before we get all that silver dissolved out of there. Again, I'm putting in half a liter of distilled water, and I'm going to add about half a liter of concentrated nitric here. Going in. And we'll cover that back up. And put it up on the heat. And let it continue to dissolve out the base metals and the silver. Alright, I started working with the imported gold about 5 o'clock p.m. I started this process of dissolving base metals out at 6 p.m. Right now it's 10:30 p.m. and this is our 4th treatment. I'm going to pour this off now. It's been boiling in nitric acid for 4.5 hours. This is where it gets kind of lengthy. When you first start this process, the nitric acid has access to the outside of those pieces of gold, and it goes quickly. But now it has to work to burrow down in to the core of each of those pieces of imported gold, and it's going to take a little longer now. I'm going to rinse the gold off a little bit here. Using distilled water, can't use tap water. And I'll pour this rinse off into my silver jar here. And now what we'll do, this will be our 5th, let's look at this, man. This will be our 5th dilute nitric treatment. Pieces of gold are starting to look brown, less bronze colored. What I'm going to do is add the distilled water here. And I'm only going to put in about maybe 300-400 ml of this. I'm going to go a little bit lighter on the distilled water now. That's about 300 ml of distilled water. Nitric acid going in. This is going to be about 200 ml of nitric. And then we'll shake it up, put it back up here on the heat. Cover this up. Cover this up and get it back up here on the heat and let it cook some more. And this is nitric treatment number 5. And both of these silver jars, this one and this one, are going to have lots of silver in that solution, and they'll both probably have a little bit of excess nitric in there, so I'll add some pieces of silver to both of these. This one's already got some in it, if you can see down here, but I'll add some sterling silver to this, and we'll consume the rest of the nitric and get our silver in solution using the residual nitric that's in this silver jar. It's midnight. I've got to get some rest. I'm going to pour this 5th nitric treatment off, and I'm going to add some fresh nitric to it. But I'm going to leave the heat off and go in and get some rest, and I'll come back out tomorrow morning and we'll pick the process up after I get a little bit of rest. Oh yeah, that gold is looking good now. Nice and brown. That's what we want to see. I'm going to add just a little bit of distilled water here. And I'm going to put nitric in there with it. That's about 200 milliliters of distilled water. Cover this with nitric acid. That's about 250 milliliters of nitric in there now. I'm just going to leave this in the burner while I go in and get some rest. I'm going to turn off the heat. We'll come back out tomorrow, pick up where we left off. Here we are, 6:30 a.m. the following morning. Had to go in and get me some rest there. I'm going to crank some heat to it now. We should be able to get this finished up. Maybe after this treatment, we should be done with these nitric treatments. So far, I've got 7 hours invested. Our solution has been on boiling back here. As you can see, there's very little fumes being produced. If you noticed, as I've been pouring these solutions out of that beaker, the solution has been green. I'm going to test our solution with some dimethylgloxine here, and we're going to see if we've got palladium in solution. I've got a little bit of the DMG in water here. It doesn't dissolve very well in water, but there's enough in here to allow me to do the test. So what I'm going to do is get one of these test tubes here, dip a dropper into our solution. It's green, and sometimes when we get a green solution, that could mean a surprise for us, because green could mean palladium in solution, but it could also mean iron in solution, or nickel. So now I'm going to take a little bit of the DMG here. Let's see if we get focused in on this. Take a little bit of the DMG, and we're going to add it to our sample here. Turn that heat down. We're starting to get a little bit of bump in the reaction vessel there. And we'll just add the DMG to our sample, and we'll let that set for a little while. Alright, while I'm waiting for this test result here, I'm going to move my silver jar back out of the way. I'm going to move this out of the way. And what we'll do now is, I've got another jar here that I'm going to add some silver to. And our solution back here is ready to be poured off. So what I'll do is reach back in there and we'll get this solution out of our beaker. See what we got inside there. I'm putting on leather gloves here. I need these in order to be able to grab that hot beaker. Alright, let's get this solution poured off of here. This will still have tons of nitric acid in it. That was our 6th boil. This will be good for dissolving more silver. Alright, if you look in there, you'll see that our gold is nice and brown, caramel colored. That's exactly what we want to see there. I'm adding distilled water to the brown gold here. It looks like all the base metals and silver have been removed from this now. It's just some nice brown flakes. And what I'm going to do is boil this for about 20 minutes or so in distilled water and see if we can get all the base metals and silver out of here. I'm going to boil this now on low heat. Okay, I've got a result here on our Palladium test. As you can see there, we've got a cloudy solution there with some yellow precipitate from the DMG reacting with palladium in our solution. The palladium is soluble in nitric acid, and our Karat scrap probably had some white gold in it that was alloyed with palladium. That's where this palladium came from. So we got palladium. Here's a better shot of our DMG test. You can see the palladium precipitate sitting on the bottom of our test tube there. Our gold has been lightly boiling now in distilled water for about 40 minutes. What I'll do now is I'll pour off the boiling water to our silver jar. The purpose of this water boil is to get as much of the green liquid, silver, base metals, and palladium out of our gold as possible. Alright, if you look in there, there's our nice brown flakes of pure gold. And what we'll do now is I'm going to add some more distilled water here, and we're going to do one more nitric acid boil, just about 150 ml or so of distilled water, 150 ml of nitric acid. And the longer we spend here with the nitric acid, the fewer problems we'll have later on when we go to refine the gold with aqua regia. We want to remove as much silver and base metals as possible. So this is our 7th nitric acid boil here. Number 7. It's been about a half hour since I added the 7th nitric acid treatment, and I'm getting some fume production in there. The longer we let this gold sit on the dilute nitric acid, the fewer problems we'll have when we go to dissolve it with aqua regia. Our solution has been boiling now for about half an hour, 45 minutes. I'm going to turn the heat off here. And now what we'll do is I'm going to pour off the hot nitric acid. All the fume production has ceased. Pour this acid off and we'll save it because it can be used to still dissolve some silver and base metals in future refining operations. Broke. My funnel broke. Yeah, my funnel cracked all the way down there from that hot solution that I poured in there. So this is trash. What I'll probably do is put this in a bag and bust it up into pieces and save the pieces for boiling granules. Now what I'll do is rinse the gold off as best as I can with some distilled water. We'll add that to the add these rinses to my silver jar. Here we go. We're going to start adding hydrochloric acid to the gold now. And I'm going to add probably about a liter here to start with. See if I get this poured in there. Kind of awkward doing this on the camera. You'll see I get an immediate reaction. That's from the residual nitric acid. And that was right at 1 liter of liquid. I'm going to start adding some heat here. I've got 200 milliliters of nitric acid measured out in this beaker. Start adding that to form aqua regia in there to get this gold dissolved. Alright, that was about a 25 milliliter dose of nitric. I'm going to add some more of the nitric here. I just put in about 25 milliliters. I'm going to add another 25 or 50 or so here. Let's see what I got. I got about 125 left, so I've got 75 milliliters of concentrated nitric in there right now. It's been about 10 minutes since I added the first 75 milliliter dose of concentrated nitric acid. I've got the heat on medium low. We've got 1 liter of hydrochloric acid in there with 75 milliliters of concentrated nitric, and the reaction is progressing smoothly. And this is exactly what we want to see right here. The gold is going into solution now with aqua regia. It's been about 15 minutes since I added the first dose of nitric. I'm going to add a little bit more here. Okay, we're down to about 75 milliliters left in the beaker. So I've got 125 milliliters of concentrated nitric acid in our beaker now. I've got 100 milliliters of nitric left in this beaker, so that means I've added 100 to our reaction vessel in there. And if you look underneath the bottom there, it looks like everything is gone into solution. I don't have any more pieces of gold in there. All I have is like a gray colored residue on the bottom. So I think all the gold is dissolved. It took about 30 minutes. I'm going to turn the heat off now. And we'll pull this beaker down off the heat and let this cool off so we can do a filtering on it. Get a temperature on this solution here. I've got 76.2 Celsius, 169.5 Fahrenheit. I'm going to let this cool down, let it settle, and then we'll get it filtered and see what we got left in the bottom of the beaker, if anything, to dissolve. I'm going to go ahead and filter this out now. Curious to see what's down at the bottom of the beaker here. Gray colored material, not quite sure what that is. Get it all into the filter. I've got everything through the filter now. I've got a bunch of gray material in this filter. Not quite sure what that is. We'll save the filter and add it to my paper storage. As I was filtering this, I realized that I did not add sulfuric acid to precipitate out lead. So if there's any lead in there, we'll have to get that out on the next precipitation. What I'm going to do now is add the solution here to my beaker. I've got it full of ice, and we're going to precipitate this gold now. I've got some sulfamic acid standing by just in case I overshot with the nitric acid to dissolve the gold. Here we go. I'm going to add sodium metabisulfite now. We'll do this first precipitation. It's full of ice because there's going to be some heat. There's almost 9 troy ounces of gold in here. Not too bad. Not too bad of a reaction there. Must have hit it fairly close with the nitrate. Not bad. So far everything's going pretty good here. If there is excess nitric in there, what will happen is I'll create a lot of heat and I'll get some brown fumes. And I don't see any of that right now. So I think I'm going to be good here, precipitating out the pure gold. Alright, let's give this a stir. Oh yeah, it's nice and cool. Alright, I think I still see some gold in there in solution, so I'm going to add some more sodium metabisulfite here. Precipitate. I see some fumes forming now in there, so I probably, if you look, if I put the lid on, you can see some fumes forming in there, which tells me I've probably got a little bit of excess nitric in there. Alright, you can tell by the fume production here, and it's starting to heat up a little bit, that I've got some excess nitric going on in here. There's 2 ways to get rid of this excess nitric at this point. One would be to add some sulfamic acid, and the other is to just keep adding sodium metabisulfite until all the nitric gets consumed and the gold stays precipitated. I'm going to give it a small dose of sulfamic acid here to see what happens. If there's a lot of excess nitric in here, I'm only putting half a spoon in, but it'll flare up pretty good when I put it in there. See that? You don't want to put this in a whole lot at a time because it will boil over, especially if you stir. This is sulfamic acid reacting with the nitric acid in there. And you got to do this real careful or you could boil your solution over. Alright, there's about a teaspoon. I'm going to put it in now. Try to get rid of this excess nitric. I'm going to keep adding small shots of sulfamic acid here until that reaction dies down like that. It's not as bad now, it's starting to go away already. Add about a little bit more here, level spoonful in here. I should be pretty close to having it all gone now. Don't get much of a reaction like I was when I first started putting it in. I'm going to add a few pieces of ice here. This is all I got left until I make some new. Alright, here we go. We're going to go ahead and add some more sodium metabisulfite now. See if we can get this gold to come out of solution and stay precipitated. It's looking a little better now. Heard something pop in there, man. I wonder what that was. Alright, I scraped some more ice off the inside of the freezer there. Go ahead and try to add that here to keep the solution cool. Add a little bit more SMB in here. That white foam's looking good. That's what I want to see. That's a good indication we got all the gold precipitated. I think we're done precipitating the gold here. This is a large amount of gold. I'm not used to refining this much, so I add overshot with the nitric. And as you can see, all the gold is precipitated now. Okay, hit that precipitation just right. I got to go have lunch with my two friends, Paul and Bubba, and gave this an opportunity to settle completely. And there's a little bit of an orange tint to this waste that I'm drawing off. And I think it's got a little bit of platinum group metals in it, but not enough to try to recover. So I'm just going to draw it off into my temporary waste container here. I tested this with stannous. It looks like a little bit of palladium. So, alright, there we go. Filter the gold out now. Get it in this filter here. And then we'll dissolve it a second time and precipitate it a second time. Not used to working with this much material here. Alright, I'm going to set this up here out of the way. I've got a large 2-liter beaker down here. I'm going to get our funnel with our gold in it. And I'm going to transfer this gold down into this beaker here so we can dissolve it a second time. Alright, we got this second filter full of gold. And I'm going to go ahead and add it to this large beaker. I was going to try to dissolve in this smaller one back here. But with this amount of gold, I decided to go back with the 4-liter beaker here. Just makes more sense. Add it to my big beaker here. And try to get everything all in one. So we can dissolve this a second time. It's not going to cooperate, of course. Stick it to the bottom of the beaker up here. There we go. Okay, before I forget, I'm going to add concentrated sulfuric acid here to make sure that we precipitate out any lead. That's about 3 milliliters. Alright, we're going to add hydrochloric acid to the 1,000 milliliter level, maybe just a little below that. That's probably 850, 900. Let's go down off the walls here with some distilled water. Cover it up. Get it up on the heat. Still got 100 milliliters of nitric acid in here. I'm going to add about half of this to the gold. Okay, for this second dissolving, it's 3 o'clock right now. I just added about 50 milliliters of nitric. It's 3 p.m. I've been on the heat now with the aqua regia for about 20 minutes. Ouch. Kind of warm. can see down there, there's quite a bit more gold that has to be dissolved. Put in a little bit more nitric here. It should take way off because it's real hot. And the reason this is taking a little bit more nitric than the first dissolve is because there was residual nitric acid left in the gold after we took the silver and the base metals out. So it's going to take a little bit more nitric to dissolve everything this second time. It's 5:30. Took 2.5 hours to get this gold to dissolve. I had to add the initial 100 nitric, 25 additional milliliters of nitric, and 200 additional milliliters of hydrochloric. Now we're going to let this cool down so we can filter and precipitate a second time. It's been chilled with ice. Filtering is almost complete. And I can't remember the last time I seen a better looking solution than this. Crystal clear, no traces of cloudiness. I've got a beaker full of ice here. What we'll do is transfer the solution into this beaker. It's crystal clear, looks really good. Precipitation is sodium metabisulfite. Made a special filter paper insert here so I can catch all the gold. I'm going to filter the gold out of the solution there. The solution is waste, and we'll go to the stock pot. We'll get that gold in that filter there, and we'll put it into a melt dish and melt it up into a nice bar. Here's our filtered gold. It's a nice cake here. I'm going to try to get it into this melt dish so we can melt it up into a nice bar. Holy cow, I did it. Got it in there with only a few crumbs spilled. Can't believe that. Alright, here we go. Here's our bar of pure gold. It's got some nice pour lines on it. Very nice. Alright, here's our nice bar of pure gold. And that thing looks great, man. Let's get a weight on it. We've got 274.0 grams. Let's see what that is in troy ounces. Alright, I got 8.8 troy ounces. 24K pure gold bar. Alright, we took some numbers here before I started, and we were looking for a yield of 279.63 grams of pure gold, and we got 274.0, so we're off by about 5 grams. But that's probably waste that got into my waste stream out there that'll get recovered later on. It's a fantastic looking gold bar. Well, this will conclude the gold refining video. The Karat scrap that I had there accumulated got me a nice 8.8 troy ounce bar, valued at just over $11,000. We'll get this turned in tomorrow. That'll conclude the video. Thanks for watching.